Okay, guys, now I want to look at number 20 in the book. Number 20 says, if 1 gram of strontium-90 is present initially, and 2 years later 0.95 grams remains, how much strontium-90 will be present after 5 years? So this is the same sort of question, except for we have to pick off the information. So think about how you can do that. Maybe try it real fast. Maybe pause the video, give it a try. And I will show you our situation. So it looks like this thing isn't decaying very quickly, right? But after 5 years, let's see what we're going to end up with. So for number 20, here's what I wrote down. I said y sub 0 is equal to 1 gram. After 2 years, there's 0.95 grams. So when t is equal to 2, y is equal to 0.95. What we want to know is, when t is equal to 5, how many grams are there? What is the y? So I'm going to use this same sort of model, y equals y sub 0, e to the kt, all right? And I'm going to go through and do what I can. So from the first bit of information, I know y equals e to the kt, because y sub 0 is 1. Now this little start information, let's use that. So I know when y is 0.95, that's equal to e to the 2k. So we're right there. And that's fine. So what do? Now I take my natural logs, and it's the same sort of mathematical process, right? So I go through, I say, okay, well, I can use my property of logs to say this is equal to 2k times natural log e, which we know is just 1. So it looks like k is going to be equal to 1/2 natural log of 0.95. Now, sometimes, especially when you plug it into a calculator, this is easier to type in as a decimal, say rounded to the nearest 1,000th. So I could also say k is about equal to, if I multiply that out, negative 0.0256. So I guess this is actually to the nearest 10,000th. So there's k. That doesn't give me my answer, but it does give me my model. Y equals e to the negative 0.0256 t. And what I want you to notice is this is negative once again for our k value. Since it's negative for our k value, we know it's decay, and that makes sense because this thing is decaying. So for 5 years, when t is equal to 5, let's see what our y is. Y equals e to the negative 0.0256 times 5. You plug that into your calculator, and you should get about 0.88 grams. Now, the book didn't ask this, but what if there was an additional question, okay? What if there's an additional question and it said, when will there be half of the initial strontium, okay? So that's the same thing as asking, when is there 0.5 grams? What we call that is, what is the half-life, okay? The half-life is when half of the initial substance remains. So it's a time. What's the half-life? Oh, maybe 500 years. It takes 500 years for half of it to decay. So if I wanted to find that, okay, that's saying t is equal to what when y is equal to 0.5. So it's like we're reversing the question. Well, we know our model is y equals e to the negative 0.0256 t. So let's see if we could figure that out. That would mean 0.5 is equal to e to the negative 0.0256 t. And we could solve for t. Taking natural logs, using our properties. So we can also solve for times on this, and you'll see that in the homework, okay? And we use our property, natural log of 0.5 is equal to negative 0.0256 t. So it looks like the time would be the natural log of 0.5 divided by negative 0.0256. Now, you're saying, well, wait, it can't be negative. Well, the bottom's negative, but natural log 0.5 is also negative. I don't have my calculator on hand, but that's probably a good number of years, and you can see that for yourself. So be aware of how to do something like that.